all have learned about different terms related to motion in one dimension. Now, today I am going to continue and start with graphical representation of motion for the 9th standard. Okay. Now, what is the need of graphs in motion in one dimension? Now, graphs will help you in understanding motion in a better way. It will give you an idea of velocity of the moving object. It will also give you an idea of acceleration of the moving object. Okay. So here there are three types of graphs which you will have to learn. The first one is displacement time graph. Second one is velocity time graph, and the third one is acceleration time graph. So we'll start with the first one, that is displacement time graph. Another thing, when the motion is in a straight line, you find displacement time graph is same as the distance time graph. Same with velocity. Velocity time graph will be same as speed time graph, and towards the end it is acceleration time graph. Right? So first I am going to start with displacement time graph. Now here there are three cases possible, so we'll study each case separately. The first one is in a displacement time graph. You have always remember time, which is an independent quantity, or any quantity which is an independent quantity comes on the x-axis, and the dependent quantity comes on the y-axis. Right? So on the x-axis you have time in seconds, and on the y-axis you have displacement in meters. Alright, so the first case is wherein time will be 5, 10, 15, 20 and so on. You can have 10 meters, 20 meters, 30 meters, 40 and so on. Now, I draw a line parallel to the time axis. For example, at 30 meters, I am showing a line which is parallel to the time axis. So, what information does this graph give? Now, from this graph, from displacement time graph, you can find out velocity of the object. Now, if you look at this graph, the object, when after 5 seconds, you find the object is at a distance of 30 meters from the starting line. After 10 seconds, you find the object is still at a distance of 30 meters from the starting line. After 15 seconds, you find from the starting, again the object is at a distance of 30 meters. So what information do you get from here? Now in fact you find that the object is not moving at all. Even after 20 seconds you find the object is at a distance of 30 meters from the starting point. So that means the information that you get from this displacement time graph, which is parallel to the time axis, is that the object is stationary object. So this is the first type of graph. Now in the second case, in the second type of graph, we'll see you have displacement time graph, time in seconds, displacement in meters, have 5, 10, 15, 20, 10, 20, 30, 40. You have a straight line like this. Okay, you have a straight line like this. Now, what information do you get from such a graph? Now you see that after 5 seconds, the object is being displaced by 10 meters. After another 5 seconds, you find the object is being displaced by 20 meters. After another 5 seconds, you find the object is being displaced by 30 meters. That means the information that you get is that here this displacement time graph represents uniform velocity. So such a graph represents uniform velocity. Now how do you find the velocity? Before telling more about this, I just come to this graph. Now here you find velocity of the object here is 0. The reason is because this graph is parallel to the time axis. So since the object is not moving, you find the velocity is 0. Whereas in this case you find, now you have a line which is passing through the origin, there is a straight line passing through the origin. So in this graph you find, in order to find a velocity, you have to find a slope of this graph. Now slope of this graph will give you the velocity of the moving object. Now how do you find the slope of this graph? I can take two coordinates between, so you have to drop a perpendicular and then parallel from this line and a perpendicular. So if you know this distance, using the formula, slope is given by y2 minus y1 upon x2 minus x1. So y2 is your this coordinate, that is 30 minus 20 divided by 15 minus 10, which is 5. Okay, so so you get 10. 30 minus 20 is 10 divided by 15 minus 10 is 5. So you get the slope as 2 meters per second. So velocity with which this object is moving is 2 meters per second, and it will be the same throughout. Okay, this is the second type of the graph. Now suppose in the third case, have a case wherein on a displacement time graph, you have a curve like this. Okay, you have a curve like this, and now in this case you find it's a curve. So from now the what information do you get about the velocity of the object? Now here you find the velocity will not be constant, so it represents non-uniform velocity. Now in case of such a graph, you can find a slope of the graph by just considering any one point, and you can draw a tangent to that point. So suppose this is the point into consideration. This is the point under consideration. So you find you have to draw a tangent to this point, and then drop a perpendicular from here, drop another perpendicular, find these coordinates, find y-axis coordinates, and using the formula, slope is equal to y2 minus y1 upon x2 minus x1 to get the coordinates, and then you can find the velocity of the object at that particular point. So it gives the instantaneous velocity. So these are three graphs related to displacement time, which helps you in understanding or in finding the velocity of the object. Okay, the second type of graph which we are going to learn is velocity time graph. Now, what information will such a graph give? Now, from a velocity time graph, you can find the acceleration of the object as well as the distance covered by the object. Okay, so the first type is wherein you have a line which is parallel to the time axis. So when you have a line parallel to the time axis, what is the information that you are getting? So we'll interpret the graph as, now after 5 seconds, the velocity of the object is 30 meters per second. After 10 seconds, the velocity remains at 30, and after 15 seconds also the velocity is still 30 meters per second. Is there any acceleration in this graph? No. So there is no acceleration. So here velocity remains constant, acceleration is 0. So there is no acceleration here. So you cannot say, so you cannot find a slope. Slope is in fact 0 here. So there is 0 acceleration in such a type of a graph. Now we move on to the second type of graph under velocity time graph. Suppose it's a straight line passing through the origin. Now in such a case, velocity time graph where you have a line passing straight, you can find the acceleration. So we'll learn more about this type of a graph. So here you find after 5 seconds velocity is 10 meters per second. After 10 seconds, suppose velocity is 20 meters per second. After 15 seconds, velocity is 30 meters per second. So in such a graph, you find it is a case of uniform acceleration. The object is accelerating slowly because after 5 seconds it is 10, after 10 seconds, so velocity is increasing at a constant rate. So you have a line which is passing through the origin. So in this case, this represents uniform acceleration. Now in order to find the acceleration in such a case, you need to find the slope of this line. Using the same method, slope is given by y2 minus y1 upon x2 minus x1. So suppose I take two coordinates, one coordinate here and another coordinate over here. So you get 30 minus 10 divided by it will be 15 minus 5. Okay, so you're going to get 30 minus 10 is 20 divided by 10. So you get 2 meters per second square as the acceleration of the object. So the slope of this line gives acceleration. Other information that you get from such a graph is that you can find out the distance covered, or you can find the displacement. For that you need to find the area enclosed under this graph. So if I draw a line here like this, so this forms a triangle. So you will have to use the formula of area of a triangle. Now area of a triangle is given by half base into height. So that will give you the distance covered. So which is equal to half. Now base is 20 seconds. 20 multiplied by a height is 40. So you get 400 meters. 40 multiplied by 10 is 400 meters. So the distance traveled by the object in this case is 400 meters. So what information do you get? You can find out by finding the slope, you can find out acceleration from a velocity time graph, and you can also find out the distance covered from a velocity time graph. Now if you want to represent retardation, okay, retardation is when an object which is having higher velocity, it comes down to 0. Okay, so if I show a line like this, on a velocity time graph for such a line, when there is, now here in this case you find the velocity decreases from 40 meters per second, velocity decreases to 0, that means the object is stopping. So this is a case of retardation. So when the retardation is uniform, so if you calculate, you can, using the formula, you can find retardation as well. Okay, and the next type of graph is wherein suppose the initial velocity is some value like 10 meters per second. you have a graph like this. That is, initially the velocity is not 0, the object is not starting from 0, instead it is having some velocity here. So in this case, now how do you find the area of such a graph to find the distance covered? If you want to know the distance covered, you have to divide it into, you can use the trapezium because this figure resembles a trapezium, or you can divide it into two parts. If you divide it into two parts, you're going to get a rectangle and you're going to get a triangle. So you can use length into breadth to find the area of this portion, and you can use half base into height to find the length of, area of this portion. Divide both the areas, so you're going to get the total distance covered. And slope you can find by using the formula y2 minus y1 is equal to x2 minus x1 for this part. Now here, so from a velocity time graph you can find out the distance covered as well as acceleration that is being produced. Okay. The third type of graph is acceleration time graph. Now on an acceleration time graph, if I draw a line which is on the time axis, okay, there is a motion which is represented on the time axis. Now what information do you get from this type of a graph? You can see here that acceleration is in fact 0. So there are two things possible when you have a line like this. Either the object is stationary, so there is no acceleration, or it could so happen that the object is moving with, you can say, certain velocity, which is a constant velocity, right? So in this case, you find there are two cases possible, right? Now on the second type of a graph, you find is a line which is parallel to the time axis. So you have line parallel to the time axis. So what information do you get from this graph? After 5 seconds, acceleration is 20 meters per second. After 10 seconds, acceleration is 20 meters per second. After 15 seconds, acceleration is 20 meters per second. So this is a case of uniform acceleration, right? So here you have uniform acceleration present, whereas in this case you find the object is moving with uniform velocity but acceleration is 0 in this case. And the third type of acceleration time graph is wherein I show a line like this which is below the 0 mark. Okay, so that means this represents negative acceleration, or it is called as retardation. Okay, so in the first case we have learned about 0 acceleration. In the second case you will have learned about uniform acceleration. In the third case there is retardation present. Now I am going to explain about motion, or you can say free fall of an object, motion under gravity. Motion when an object which is thrown from a certain height. So due to the presence of gravity, due to the Earth's gravity, that object will get accelerated towards the surface of the Earth, right? Now in that case you find, for such now you must be knowing that acceleration due to gravity is constant on the surface of the Earth, and it has got a fixed value. it is denoted by g, which is equal to 9.8 meters per second square. When an object is being released and it is falling with an acceleration of 9.8 meters, usually we take it as 10. For problem solving purpose, we take it as 10 meters per second square. So when an object is falling freely, if an acceleration time graph will be a line which is parallel to the time axis. That means after 5 seconds, after 10 seconds, the acceleration remains constant. If you have to draw a velocity time graph, you're going to get a velocity time graph will be a line like this. So that means it represents uniform velocity. Correct? So this is the information that you get from motion under gravity, and if at all you have to show a displacement time graph, will be a curve like this. This is true for motion under gravity. Now towards the end, I'm going to show the motion velocity time graph for a ball which is released from a certain height. Graph of a ball which is released from a certain height. So velocity time graph. So you have the velocity here, time here in seconds. Okay, when an object is released from a height, for example a ball, so initially at this point, now this is 0, so the object will not have any velocity. So you have to start the velocity line from here, correct? So as you release the ball, you find as it is hitting the ground, it will have uniform, it will move with a uniform velocity. The moment it touches the ground, it will hit with maximum velocity. So you're going to get a line like this. You're going to get a line like this. The moment ball reaches the ground, its velocity will become 0. Okay, its velocity will become the ball is over here, which is maximum velocity. The moment it reaches the ground, velocity will become 0 and then it will rise. So as it is rising, you find again velocity is increasing but in a negative direction. Okay, it's slowing down in fact. So you can start, so as if it is starting from here, velocity is not increasing but it is slowing down. So again I can start it from here. So after 30 seconds, the velocity will again come to 0. So the ball is going, initially velocity is 0, it is increasing, it reaches its maximum value and again it is rising. So you can show it over here, from this point you can show it over here, and eventually the velocity becomes 0, right? So this is a case where you have a ball which is being released from a certain height. Okay. So in the next class, I'll be showing you all equations of motion. Thank you.